Hello friends, welcome back to my YouTube channel Code with Ramveer. In the previous videos, we have learnt about what is time complexity, what is space complexity, what is big O on rotation. Now there is one more important concept that has been asked in interviews is the amortized analysis. So this is very important from interview point of view. So we'll discuss this amortized analysis in this video. So it's going to be a good video. It's going to be a very important video. So don't skip the video. Please watch the video till the end. So what is amortized analysis? Amortized analysis is basically average cost over multiple operations, not a single operation. So it's the average cost over multiple operation, not a single operation. So it's been asked in the interviews. So we have to analyze this, how we can calculate this amortized analysis. Okay. So in the real example, if you have an array list in Java, the array list grows basically dynamically. So whenever sometimes you perform add operations, sometimes there is resize operation. So when you perform the add operation, so add the time complexity is O of 1, and you when you perform the resize, the complexity is O of n. So what's the complexity? Then how to calculate this complexity? That's a big question. So I'm going to tell you about this, how to calculate this complexity or this in this video. So let's see here. So the correct answer is amortized complexity is big O of 1. Why? That's a big question, right? So resize happens rarely, and cost is spread across many insert. So basically your array list is resizing rarely, but the cost is spread across many inserts. Now let's see this. If you find this difficult, we'll make it easy. Now what we are trying to explain, we are trying to explain why ArrayList dot add is amortized O of 1, even though the resize itself is O of n. So let's understand a scenario where you have an array list and you have a empty array list that is considered to be a row of boxes. So initial capacity, assume that the array list is having 10 and size is 0. So every you are adding the element into the empty boxes. So it will look like something like this. You have arrest which is having initial capacity as 10 and size is 0. You are adding the elements. Add 1 O of 1. Add 2 complexities O of 1. Then for the first 10 add, the resizing is not happening because the elements are added up to the capacity. Now if you want to add the element into the array list, now this is where the key thing happens. Up till here we have added the 10 elements, so the cost is constant here. Okay, now if I want to add the 11th element into the array list, so what does a Java do internally? Java creates a array list of double size. So if the capacity, the previous capacity was 10, now the new capacity is 20. So what it does is it copies all the 10 elements to a new array and add a new element, that one, that is the 11th one, into the new array. Okay, so this is a resize. This is a resize. It is happening once. Okay, so yes, let's visualize this in pictorial form. So old capacity was 20, new capacity, old capacity was 10, new capacity is 20. So resize is happening at add 11. Okay, right? So the again, if you want to increase the capacity, or if you want to add further more elements beyond the array list size, it can also happen. So you have various resizes here, At the capacity 10, the resize occurs at 11, and capacity 20, the resize occurs at 21, and 40 resize is occurring at 41. If the capacity is 80, the resize is at 81. So that is basically, this resize is really confusing part. Now we are going to discuss this. So cost of this ad is O of n, right? We are resizing, so cost is O of n, and that's why this is where the trap is. The most of the candidate panic and says the array list ad is O of n. This is absolutely a very wrong answer, right? This is not the right answer. Now let's discuss this one. The key insight is here is the expensive resize does not happens at every ad, right? It is not happening at every ad. Let's look at the example where you have 1,000 array list size. So you have initial capacity resizes is happening at 10. If you have capacity as 10, the resize is happening at 11. Similarly, if you have a capacity as 20, then resize is occurring at add 21, and so on. So this is what I want to show you, that the resizes are rare, and we have most of the add operations, right? So if you look for this key realization, that is total number of works, that is adds, total number of add is 1,000, so that is proportional to 1,000, not 1,000 into 1,000, right? So total work for 1,000 adds, whatever the 1,000 elements we are going to add, that is basically proportional to 1,000, not 1,000 into 1,000. So the total cost is O of n, right? And number of operations we performed n, right? So if you simplify this, that you have 1,000 add operations and only 10 resizes. Each resize cost, if each resize is costing you O of n, then the total cost of all operations is linear. That is equal to linear, right? So if we are calculating this cost of amortized analysis, so it's kind of a linear, right? Now here we need to analyze the average cost. If you want to calculate the average cost per operation is basically total cost, whatever you have total cost, and that is basically divided by number of operations. So our total cost was O of n and number of operations were n. So that is equal to big O of 1. Therefore, the average cost per operation is total cost divided by number of operations, and that is basically nearly a constant value. So that's why amortized time complexity is O of 1, big O of 1. So that is a key point in the interview. So if this video helped you a little in understanding amortized analysis, please like the video, subscribe the channel for the latest, for watching the uh, LeetCode series, right? Hit the bell icon for getting the latest notification of the videos. Till then, it's happy coding from Code with Dharamveer. Thank you. Thanks for watching this video.